Hello everyone, welcome back to Algebra 1-2. Our topic for this lesson is the remainder theorem, and so in this video you will learn about the remainder theorem and how to apply it. The best way to start is just to do some division, and here we want to divide x cubed plus 1 by x plus 1. And since we're dividing by x plus 1, it seems fitting that we use synthetic division to get through it pretty quickly. So let's set up our division. We want to divide x cubed plus 1. So we're going to start by writing down minus 1. And remember, since there are some missing terms here, the square term is missing and the x term is also missing. So we put in zeros for those and write back our 1 there. And now we put our plus sign and we begin using our synthetic division. So we're going to multiply negative 1 here by 1. That gives us negative 1. We write it under this 0. Add these two. Negative 1 plus 0 is negative 1. Now we're going to multiply negative 1 times negative 1. That gives us a positive 1. We write it here. 0 plus 1 is 1. And negative 1 times 1 is negative 1. And we add these two and we get a 0. Of course, we write back that 1 here. And so what we get then is a polynomial of the form. Starting here, notice this is x cubed, so we have to go one degree lower. So we're going to write down x squared minus x plus 1. And so this is what we get. There's no remainder, or there's a 0 remainder here. So this is what we get when we divide x cubed plus 1 divided by x plus 1. And so we can write it in the form that x cubed plus 1 divided by x plus 1 is equal to x squared minus x plus 1, or we can write it alternately as x cubed plus 1 is equal to x plus 1 times x squared minus x plus 1. And so what we have here is that our polynomial x cubed plus 1 is equal to our divisor here times our quotient. This is our quotient here. So the divisor times the quotient. Here's our divisor times the quotient. Now let's look at the other one here. We're dividing x cubed plus 2x plus 1, and we're dividing again by x plus 1. Let me just push this a little higher. So again, we're going to use synthetic division since we have an x plus 1 here. So let's set up our x plus 1. We're going to divide by that. So we have the cube, the square is missing, square term is missing. So we have put in a 0 for that. And then we have 2, and then we have 1. So we're going to put our plus sign, and then we're going to go ahead and perform our synthetic division. So negative 1 here times positive 1 gives us a negative 1. Add those, we get negative 1. Negative 1 times negative 1 here gives us a positive 1. 2 plus 1 here gives us 3. And negative 1 times a positive 3 gives us a negative 3. And negative 3 plus 1 here gives us a negative 2. Of course, we drop out that 1 here. And here we get a quotient and a remainder. So our quotient will have these coefficients. And this negative 2 here is our remainder. So because we have x cubed, we go 1 degree less. So we're going to have x squared minus x plus 3, and we have a remainder of negative 2. So it's we could say plus negative 2. Let me just write it as minus. So let's write minus negative 2 over what we're dividing by, x plus 1. So sometimes when we're dividing, we get a remainder. And sometimes when we are dividing, we have no remainder. So that is the case when we're dividing. We can rewrite this. X cubed plus 2x plus 1, in this case, is going to be equal to our divisor, which is x plus 1 times our quotient. Our quotient is this, x squared minus x plus 3, and plus our remainder. So sometimes it happens that way. The quotient, the divisor times the quotient plus the remainder. And essentially that's what the remainder theorem deals with and how it works. So if we have p of x as a polynomial of degree n, whatever n is usually an integer. So if p of x is a polynomial of degree n, then p of x is equal to our divisor, which is this, multiplied by our quotient plus the remainder. As you see it written out here. In this case, there was no remainder, and in this case, we have a remainder. So the divisor times the quotient plus the remainder, divisor times the quotient. Here we had a 0 remainder. So p of x would be equal to the divisor times the quotient plus the remainder. And of course, the quotient has to be 1 degree less than the polynomial itself. Now, importantly, we need to look at this. The remainder, r, is equal to p of a. So, in the remainder theorem, if a polynomial p of x is divided by x minus a, then the remainder r is equal to p of a. And so we need to pay very, very special attention to this. All right. So how do we use the remainder theorem? Let's look at this. P of x is equal to 3x to the 5th power plus 5x to the 4th minus 4x to the 3rd plus 7x plus 3. And what we want to do is to find the quotient and remainder when p of x is divided by x plus 2. And then use the remainder theorem to find p of negative 2. Now notice, since we're dividing by x plus 2, we're not going to use long division here. We're going to use the synthetic division method. And since we're dividing by x plus 2, we're simply going to use negative 2 in our division. So let's set it up. Negative 2. Now it's 5, 4, 3. Notice that the square term is missing. Remember to put a 0 there for it. So we have to put 3, then 5, then negative 4. There's no square term, so we'll put a 0. There's our 7, and then there's the 3. So let's make sure that they're all there. X to the 5, x to the 4, x to the 3rd, x square, x, and 3. Good, they're all there. So we can write down our synthetic division process. Now, let's just write the 3. That 3 goes there. Now, negative 2 times 3 gives us a negative 6. Remember, we're going to add these. So 5 plus negative 6 is negative 1. Negative 2 times negative 1 gives us a positive 2. Add these, we get a negative 2. Negative 2 times negative 2 is 4. Add these, we get 4. And negative 2 times 4 gives us a negative 8. Add these, we get a negative 1. And lastly, negative 2 times negative 1 gives us a positive 2. And positive 2 plus 3 here gives us 5. And what it's telling us is that the remainder, the quotient, will have these coefficients, and this 5 here is our remainder. So we can write out our quotient as, starting with 1 degree less, 3x to the 4th minus x to the 3rd minus 2x squared plus 4x minus 1, and our remainder of 5. Of course, it would be 5 over x plus 2. So we have found the quotient, and the remainder is 5. Now, the other part of the question says this is the quotient. Let's call it q of x for the quotient. So part B says use the remainder theorem to find p of negative 2. Then notice here that we use negative 2 here to do the synthetic division. And by the remainder theorem, if p of x, if a polynomial p of x is divided by x minus a, then the remainder r is equal to p of a. So to find r, we simply need to write this down. So p of negative 2 is simply 5. There's no need to go and calculate it further. Of course, you could calculate it if you wanted to check it by substituting negative 2 into this, and what you would get is 5. So p of negative 2 is 5. By the remainder theorem, it tells us that once we perform the division, the remainder that we get is equal to p of whatever that is. So if we substitute p into this function, into this polynomial, then that's what we're going to get for the remainder, and that's what it is. So let's look at another question. It says when the quadratic x squared plus px plus 1 is divided by x minus 1, the remainder is 5. Now, using the idea that we learned here a while ago, that if a polynomial p of x is divided by x minus a, then the remainder is p of a. Then we can solve this easily by saying that all we need to do then, since we're dividing by x minus 1, we simply need to substitute x equal 1 into this quadratic, and we will find what the remainder is. So if we substitute x equal 1, then what we're going to get is 1 square plus p times 1 plus 1, and the question is telling us that the remainder is 5, and that tells us that 1 plus p plus 1 is equal to 5, which tells us that p plus 2 is equal to 5, and therefore we have p is equal to 5 take away 2, and that is equal to 3. If we wanted to try it using the synthetic division method, then of course we would use x equal 1, so we'd set up our 1 there, and the coefficient there is 1, the coefficient here is p, and the coefficient here is 1. Nothing is missing, so no need to add zeros. And put our plus there, and begin the process. So 1 times 1 is, of course, we write that 1 there. 1 times 1 is 1. So we have 1 p plus 1, because we're adding here. And 1 times p plus 1 is p plus 1. And now we have p plus 1, which gives us p plus 2. And so our quotient would be here, and this would be our remainder. Now the question told us that our remainder is 5. So what it's saying therefore is that p plus 2 from here is equal to 5. And therefore we know that p is equal to 5 take away 2. So therefore p is equal to 3. Either way, simply substitute it and it works out. Or if you wanted to try the other method, then it works out just the same. So this is how we use the remainder theorem to solve simple problems when we're working with polynomials. Now that you know how it's used, now that you know what it's about, it's time to go get some practice to master it. And of course, if you haven't subscribed to our channel, then please do. And of course, thank you always for your support, and thank you for watching.